Hello everyone, I'm Jyoti from BSc Chemistry Honors second year. So this video is specially for visually impaired students. The chapter name is Metallurgy from Inorganic Chemistry. Let's start. Minerals. Metals occur in nature, sometimes free but mostly in combined state. Those found in free or in native state are copper, zinc, gold, silver, and lead. The metals are found in the combined state with other elements and are obtained by mining from the earth are known as minerals. That is, copper minerals are oxide ores such as Cu2O, CuCO3, CuOH2. Sulfide minerals are Cu2S, CuFeS2, etc. Or when a mineral contains sufficient quantity of a metal combined with other element from which it can be readily separated so as to render the extraction of metal of good quality probable, it is said to be an ore of metal. All ores are minerals, but all minerals are not ores. The principles of metallurgy are were them gangue or matrix. The ores usually contains a large number of impurities like earths, metals, rock stones, sand, limestones, mica, and other silicates. These impurities are known as gangue or matrix. The ores are divided into four groups: native ores or free state. The less reactive metals like Cu, Ag, Au, Pt, Hg, and Pb occurs in free state. These metals are known as native ores. Oxide ores. These ores are classified as oxides and hydroxides. The metal like copper, zinc, lead, aluminium, scandium, chromium, magnesium, vanadium, iron, titanium, magnesium, manganese, beryllium, etc. occur as oxide and hydroxides. Carbonate. The metals like iron, copper, zinc, lead, manganese, calcium, strontium, barium, magnesium, etc. occur as carbonate or sulfate. The metals like strontium, calcium, barium, etc. occurs as sulfate ores. Carbonate. The metals like iron, copper, zinc, lead, etc. occurs as carbonate or sulfate. The metals like strontium, calcium, barium, etc. occurs as sulfate or silicate. The metals like copper, zinc, nickel, aluminium, etc. occurs as silicate. Phosphate ores. The metals like calcium, strontium are etc. as phosphate ores. Sulfide and arsenide ores. The metals like copper, zinc, iron, cobalt, nickel, lead, and gold and silver, etc. occur as sulfide and arsenide ores. Halide ores including chlorides and oxychlorides, metal like sodium, potassium, magnesium, and the silver, etc. are obtained as chlorides and oxychlorides. Nitrate ores, the metals like Na, K, etc. occurs in form of nitrate ores. Metallurgy. It is a branch of science dealing with the method of extraction of metals from their ores and preparation of alloys. Generally, few methods are used for isolation or extraction of metals, ore dressing or concentration of ore. The ores usually contains large quantities of impurities like earthy matter, rock stones, mica, feldspar, etc., which is known as the gangue or matrix. Removal of these impurities from ore is called as ore dressing or concentration of ore. These impurities from ore is called as ore dressing or concentration or ore. During ore dressing, the percent of the metal increases, so it is known as concentration. The purified ore is known as concentrate. The operations carried out during ore dressing are as follows: hand picking. The ores can be separated by sufficient degree of purity by simply picking it by hand and breaking the rock stones with hammers. The specific gravity. The ores is crushed in jaw crushers and powdered in ball mills. If the ore and gangue have different specific gravity, and if the ore is lighter and gangue is heavier, then it is concentrated by gravity separation. In this method, the powder ore falls on jockey's sloppy table and the stream of water is paused. So the ore is flown away with the stream of water and impurities fall below table from where it is removed. Magnetic separation. This method is used when ore and gangue have some specific gravity, but one is magnetic and other is non-magnetic. That is, ore is magnetic and gangue is non-magnetic. A thin layer of powdered ore is allowed to fall on a rubber belt which moves horizontally and then passes over a pulley in magnetic field. Gangue particles or the particles of non-magnetic mineral falls as the belt becomes vertical, lighter, and gangue is heavier. Then it is concentrated by gravity separation. In this method, the powdered ore falls on jerky sloppy table. stable and stream of water is passed, so ore is flown away. The stream of the water and impurities hull below table from where it is removed. I think I have already read this. This method is used when ore and gangue having same specific gravity. One is magnetic and the other is non-magnetic. That is, ore is magnetic and gangue is non-magnetic. A thin layer of powdered ore is allowed to fall on a rubber belt, which moves horizontally and then passes over a pulley in a magnetic field. Gangue particles or the particles of non-magnetic mineral falls off as the belt becomes vertical. The magnetic particles are retained on the belt until they pass out of the influence of the magnet. Froth flotation process. This process depends magnetic separation. This process depends on the fact that certain minerals are wetted by oil while gangue is wetted by water. Mainly this process is used for the concentration of sulfide ore of copper, lead, zinc, mercury, etc. The grounded powder ore is taken into a big tank. To this a mixture of water and small quantities of turpentine oil or pine oil as suitable additive is added. Then compressed air is passed through the whole mixture is agitated violently and froth is produced. The ore particles stick to the oil particles and come out of on the surface as a foam and it is collected. The impurities like earthy metals, rock stones, limestones, mica, etc. are wetted by water becomes heavier and settles down at the bottom of the tank. By using this process, the sulfide source of copper, zinc and lead are separated from impurities. Calcination and roasting. For chemical reduction, the concentrated ore is converted into oxide by calcination and roasting. Calcination, it is the process of heating the ore at low temperature. In the absence of any blast of air, the moisture, CO2, etc. are removed and the ore becomes porous. That is, when limestone is heated, CO2 is given off and it is said to roasting. It is process of heating the ore strongly in excess of air. The roasting includes the following types: oxidizing roasting. The volatile impurities like SLISSB are removed by volatile. It is used for CuFPS2, ZNS, etc. Blast roasting. The blast of hot air is passed through the ore for the expulsion of sulfur and metal is converted into oxide. This method is used for galena and copper pyrites. Chloridizing roasting. It means the conversion of a metal of ore into a chloride by heating with common salt in presence of air. Silver is converted to AgCl and then amalgamated for extraction of metal Ag. Sulfating roasting. It is a partial oxidizing roasting in which a sulfate is not converted to an oxide but soluble sulfate, that is copper sulfide to copper sulfate. These soluble salts are taken out with water and used for further treatment. Calcinations and roasting are carried out in reverberatory furnace, sometimes kilns, and also used smelting. It is a general term used for various operations whereby the metal is separated by fusion from ore. Chemical reduction by using powerful reducing agent for the extraction of rather less electropositive metal. Powerful reducing agents such as H2CO, water gas, NaK, Be, Altimg may be used. Cr and Mn are obtained by reduction of their oxides by aluminum powder. This method is known as Gold-Skimmed method. Gold-Skimmed aluminothermic process. A mixture of metallic oxide and Al powder is known as thermite and hence this process is also called thermite process. Carbon reduction process. The oxides of less electropositive metals like Pb, Zn, CuSn, etc. are reduced by heating them with coal or coke. Flux and slag. In order to remove infusible impurities, a suitable substance known as flux is added during reaction process to convert infusible impurities to a fusible material, which is known as slag. The slag is lighter than molten metal, hence it floats over the metal and is removed from slag hole. The nature of the flux used depends on the nature of impurity to be removed. An acidic flux is used to remove basic impurity. A basic flux is used to remove acidic impurity. Some ores are self-fluxing because they contain some gangue which is itself fusible and no foreign flux is required. Air reduction. This process is applicable to the extraction of less electropositive metals may be reduced without using any additional reducing agent. Higher temperature and anion present with metal bring this change, that is cinnabar is roasted in air until a part is converted to oxide On further heating, in the absence of air, the oxide reacts with unchanged HCl to give Hg. Electrolytic reduction. When the oxides of highly electropositive metal like alkali metals, alkaline earth metals, aluminum, etc., are heated with carbon at high temperature, the metal combine with carbon and form carbide. These metals are extracted by electrolysis of their oxides, hydroxides, and chlorides in fused state. Some other salt may be used to lower the melting point of the compound under electrolysis. The addition of the salts helps in electrolysis in following ways. To lower the vapor pressure of metal, it reduces the corrosion troubles point of the compound under electrolysis. The addition of the salt helps in electrolysis in following ways. For example, in manufacture of Na by electrolysis of fused mixture of NaCl and CaCl2, the reactions as, as under refining or purification of metals. The metals obtained after smelting contain greater or lesser amount of impurities. These impure metals are purified by various ways. First one is distillation, second one is liquidification, then sublimation, and then electrolysis. Furnaces. The principal types of furnaces used in metallurgy are as follows. That those are reverberatory furnace, blast furnace, open hearth furnace, muffled furnace, electrical furnace, and kilns. Refining or purification of metals. The metals obtained after smelting contain greater or lesser amount of impurities. These impure metals are purified by various ways such as distillation, liquidation, sublimation, electrolysis. As we have already read about the furnaces. In this furnace, the fuel is burnt in a separate part of the furnace which is known as fireplace. The fireplace is closed at the bottom by iron bars on which the fuel is placed and burnt. The rest of the horizontal part is known as hearth or bed. The roof of the furnace is concave and takes vent towards the end away from the fireplace and communicates with the chimney. The charge is placed on the hearth and fuel is burnt on the fireplace. So the hot gases and flames are deflected towards the hearth by the concave roof. Thus the charge is heated and it will not come in direct contact with the fuel. Since the fuel does not come in direct contact with charge, the reverberating furnace can be used for reduction as well as oxidation process. For reduction, the material is mixed with reducing agent like coke and carbon, while for oxidation, it is heated in a current of air. The calcinations and roasting are carried out in this furnace, blast furnace. It has characteristic shape. It is about 30 meter in height and 6 to 9 meter in diameter. It is made up of steel plates. It is lined inside with fire clay bricks. The hearth may be lined with carbon blocks for durability. On the top of this furnace is cup, cone and hopper system through which charge is introduced in the furnace. Air heated at 550 to 850 degrees Celsius by combination of waste gases is blown under pressure through tires or nozzles. The downcoming charge makes the upward moving hot air blast. The temperature at earth is 1500 degrees Celsius and at top is 200 to 300 degrees Celsius. The product leaves from three places. First one is the molten air is tapped from the base of the hearth every 6 hours or so. Second, the less dense molten fusible slag floating on the molten iron is tapped more frequently through separate outlet. Third, waste gases escape through the exit near the top. These gases are purified before combustion. Blast furnace is mainly used for manufacturing of cast iron open hearth function. These furnaces is used for the manufacturing of steel and works on the regenerative principle of heat economy. This furnace is known as Simon Martin furnace. The furnace is heated by producer gas burning in the furnace over the hearth. The hot producer gas passes out from the other side of the furnace. In actual practice, the hot gases are made to pass through a brick chamber and then the incoming cold gases are preheated by first passing through this chamber. In the regenerative system, the heat carried away by the fuel hot gases is not allowed to be wasted. The hot flue gases are passed through bricks chamber which gets heated, and the gases going out of this chamber are at much lower temperature. After some time, fuel gases are passed through this hot chamber, and the flue gases are made to heat another brick chamber. The fuel gases preheated in the chamber burns and supplies more heat. After some time, the currents are again reversed. Refractory material. These are the substances which can bear very high temperature without melting or becoming soft. A suitable refractory material um, a suitable refractory material bears following properties. These type of substance do not melt or soften to an appreciable extent upon exposure to intense heat. They resist sudden and great extreme temperatures. They support considerable pressure at high temperature without crumbling. They resist corrosion of slag. Refractory material are used in form of bricks for the internal lining of the material. Fuse and hotter parts of the chimney. The commonly used refractory materials according to the acidic and basic nature are as follows. Silica in form of keenstone, quartz, sandstones, etc. acidic. Fire clays consisting of 50 to 65% SiO2 and 20 to 35% alumina, semi-neutral. Graphite, chromite, bone ash, neutral. Lime dolomite, manganese, basic. SiO2 alkaline resists temperature up to 1740 degrees Celsius, bauxite bricks up to 1800 degrees Celsius, alumina up to 2000 degrees Celsius, and magnesia and chromite bricks up to 2200 degrees Celsius. Graphite is one of the most valuable material for manufacturing of the furnace. Zirconia ZrO2 is one of the most refractory substances yet known and would up to 2600 degrees Celsius unchanged. Thanks for watching.